Hello everyone, welcome to MEMONEET. I am Aprajita, your chemistry SME, and I welcome you to today's video lecture. So today we are going to revise another chapter, that is solutions for our BPT6 preparation. Okay, so this is just a recap on solutions chapter because we have discussed this chapter in detail in our previous video lectures. If you have not watched them yet, you can go and watch in the Sha Sir's batch chemistry video lectures. So all the video lectures are uploaded there in that playlist. Okay. So as you know, BPT6 is your cumulative test and all the chapters which we have covered till now are going to be asked in BPT6. So today we are going to revise this chapter, that is solutions. So I will just tell you about the important topics of this chapter and what topics you need to cover and from where the questions would be asked. Okay. So we will be starting with the first thing. So if we talk about solution, so solution is actually a homogeneous mixture of two or more components. This we have learned many a times. Okay, these are the homogeneous mixtures. So in this particular chapter, we basically talk about the binary solutions. So binary solutions are the ones in which we are having two components. Okay, if two components are there, we call it as binary solutions. Okay, so we all know the component that is present in the largest quantity is known as the solvent, and solvent is the one which determines the physical state of the solution. Means, let's say if the solvent is in liquid state, so it means the physical state of the solution would be liquid no matter what the solute is. Okay, and then if I talk about the other component, so the other component which is present in lesser quantity is known as the solute. And each component can be solid, liquid or gas. Here we have taken different types of example, like if gas and gas is there, like mixture of oxygen and nitrogen gas, you can say air, all right. So that's there. Liquid, if liquid is a solute, gas is the solvent, means chloroform mixed with nitrogen gas. So solid present can be in gas, okay, camphor and nitrogen gas. So similarly we have liquid solutions where the solvent is your liquid. Solute can be gas, liquid or solid, any one. Okay, same goes with solid solutions where the solvent is solid. Okay, so this is just a very basic thing about the classification of your solutions. Okay, now the next thing is strength. Now this is important topic. Now why it is important? Because in the from this topic a lot of numericals are asked. Okay, different types of numericals are asked from this topic. So I have taken the formulas for different types. So if I talk about the strength of a solution, so amount of solute dissolved per unit solution or solvent is called the strength. Ki how much solute is present in your solution or the solvent. And there are various methods which we use to measure the strength of the solution. First is mass percentage. Mass percentage means how much mass of a component is present in 100 grams of the solution. So here we will be taking mass of that particular component. Okay, whatever component ke liye we have to calculate the mass percentage, that we will take. So mass of component in the solution divided by total mass of the solution into 100. Okay, so जब भी हम percentage निकालते हैं, we multiply it by 100, no? So mass of component in the solution upon total mass into 100. Then same goes with volume percentage, means V by V. A volume percentage means ki how much volume of that component is present in 100 ml of the solution. Okay, so it means we will take the volume of the component divided by the total volume of solution and multiply it by 100. So that will become the volume percentage. Next is mass by volume percentage. So mass by volume percentage में again we will take how much mass of solute in grams, कि कितना solute जो कि grams में है, it is present in 100 ml of your solution. So mass of solute in grams divided by volume of solution in milliliters, okay, into 100. Fine, that will be your mass by volume percentage. Now the next one is parts per million. Parts per million is actually used to represent the concentration which is very less in amount, okay, where the solute is present in very less amount. So that we will be calling as parts per million. Parts per million means 1 in a million कि कितना concentration in 1 millionth present है, so 10 to the power 6 से we multiply it, like percent. If I talk about percentage ना, परसेंट मीन्स कि पर 100 कितना प्रेजेंट है, तो यहाँ पर हम देखते हैं पर 1 मिलियन मीन्स 1 मिलियन मीन्स 10 टू द पावर 6 में कितना पार्ट आपका प्रेजेंट है. सो वी विल टेक द नंबर ऑफ पार्ट्स ऑफ द कंपोनेंट, डिवाइड इट by the total number of all components, कितने components है, and then multiply it with 10 to the power 6. Okay, that is part per million. Now the most important is mole fraction, because mole fraction we use many a times. Okay, many times we use this mole fraction thing. So if I talk about the mole fraction, it represents mole of a solute present in 1 mole of a solution, ki how many moles of the components are there, and if we divide it with the total number of moles, so we will get the mole fraction. Okay, let's say if I am having an A moles, there are two components A and B, and Na and Nb are the number of moles of A and B. So if I have to find out the mole fraction of A, so it is represented by X. Okay, Xa kya hoga? Number of moles of A divided by total number of moles, Na plus Nb. Same goes with Xb. Mole fraction of B is Nb upon Na plus Nb. And one thing you have to keep in mind, students, ki jo sum hoga, the sum of all mole fractions will always be 1. So if you want to calculate Xb means mole fraction of B, so 1 minus Xa se you can do that. Okay, so that can be done. All right. Okay everyone, now if I talk about molarity, molarity is again very important. Okay, so molarity means number of moles of solute present in 1 liter of the solution. Molarity are the ones which are mostly used, okay, terms. Now molarity means number of moles of solute upon volume of solution in liters. Agar liters mein nahi di hai, if it is in milliliter, then multiply it with 1000. Okay, so the units of molarity are mole per liter, और इसको हम capital M से denote करते हैं, और we can say molar, like the solution is 2 molar, 1 molar, so like that we represent it. And you have to keep in mind that molarity depends on the temperature. Okay, this question can be asked in the exam. Once it was asked that which of the following properties is dependent on temperature. So why it depends on temperature? Because volume of the solution depends on temperature, and molarity mein volume is involved. So if volume will be changing, the molarity will also change. So you have to keep that in mind, that it is a temperature dependent property. Okay, next is molality. So molality means number of moles of solute present per kg of solvent. So here we will be taking the number of moles of solute and divide it with the mass of solvent in kilograms. Okay, keep that in mind. So again the units will be mole per kilogram, or it is represented by small m, or we say molar, like 5 molar solution, 2 molar solutions, like that. This will not depend on temperature because mass is involved, and mass does not changes with temperature. Okay, now another important way of representing the strength is normality. Normality is denoted by capital N. So it represents the number of equivalents of solute present in 1 liter of the solution. Okay, so what is number of equivalents? So equivalents means the weight of that particular substance divided by the equivalent weight. Now what is equivalent weight? Equivalent weight means this molar mass. We will take the molar mass of that component divided by Z. Z will be the valency factor. Okay, so that will give you the equivalent weight. So from that you can find the number of equivalents, and then you can find out the normality. Now again this important equation is there, which we call as dilution law. So if we want to like dilute a solution, so the amount of solute will remain constant. Okay, so you have to use the dilution law for finding that, like m1 v1 equals m2 v2. Okay, that will be like mass and volume and mass and volume. So in the same molarity and volume, and here also molarity and volume. So that's the molarity equation, and for normality it's n1 v1 equals n2 v2. So whenever we are diluting the solutions, we can use these equations for finding out the amount, how much it is required, okay, how much volume we will be taking. For example, if I am having let's say 1 molar solution. Okay, I'm having 100 ml of 1 molar solution, and let's say I want to make it let's say I want to make it 0.2 molar, okay, or 0.5 molar. So how much volume I have to take or how much water I have to put, so that we will be getting to know from the molarity equation. Okay, like molarity is 1 molar, so how much volume of this 1 molar solution I will take, so that I get it 2.2 molar and have to make it 100 ml only. Okay, so from here we can get to know the answer. Okay, so from here I will be taking 20 ml. So 20 ml of this 1 molar solution I will take, and rest 80 ml I will put the water, so it will become 0.2 molar solution. Okay, so there you will be finding out how to use this dilution law. Okay. Alright, now let us talk about the vapor pressure and the Raoult's law, which is very important. So you know, students, if I talk about vapor pressure, so vapor pressure of any liquid or a solution is the pressure exerted by the vapors in equilibrium with liquid or your solution at a particular temperature. Means, you know, of course the liquid is there or the solution is there, it will vaporize. Okay, so what is the pressure exerted by those vapors which are in equilibrium with your solution? So उसको हम vapor pressure बोलते हैं. Okay, and vapor pressure is directly proportional to escaping tendency. Means if the particles can escape readily, so it means the vapor pressure will be more. And then we have this Raoult's law, which tells us about the vapor pressure. Now Raoult's law actually states that for a solution of volatile liquids, let's say if we are having two volatile liquids, the partial vapor pressure of each component in the solution is directly proportional to the mole fraction. Okay, let's say I'm having two components A and B, and you can say here that their mole fractions are XA and XB, and the partial vapor pressure of A is PA and partial vapor pressure of B is PB. So according to Raoult's law, PA will be directly proportional to XA, which is the mole fraction. If I remove this proportionality sign, I will get P naught A XA. Now what is this P naught A? P naught A is the vapor pressure of pure solvent. Okay, means when it was present in pure state. So in that case, what was the vapor pressure? That is P naught A. Same goes with P naught PB. It will be directly proportional to XB. So from here, PB you can say P naught B XB. This information is very important because this you will be using to find out the colligative property also. So up now PA and PB I have, these are the partial pressure, okay, partial vapor pressure of each component. If I want to find out the total vapor pressure of that solution, so how will I find out? I will be applying the Dalton's law of partial pressure. Right, students? So in Dalton's law of partial pressure, you know that total pressure is the sum of the partial pressure of all the components. So I will put it like this: P naught A XA plus P naught B XB. Now you know I can put it like this: XA is equal to 1 minus XB. है ना? So you can put it in form of any one. P naught B XB. Okay, so from here you can find out the relation. So this is what you can talk about here. So I can write it here: P naught A minus P naught A XB, P naught B XB. Okay, so from here so you can write it like this: XB P naught B minus P naught A. So from here, students, what you can see is that it will depend on the mole fraction of the solute or the solvent. Okay, so the total pressure will be dependent on the mole fraction from here. So that's what we get to know about the solutions from the Raoult's law of vapor pressure. Okay, so Raoult's law is important. Now if I talk about the Raoult's law, if the solutions obey Raoult's law, if they don't, we get two types of solutions, that is your ideal and non-ideal solutions. So now let us talk about that. Okay, Raoult's law is important. Then another important topic that we have is the ideal and non-ideal solution. So let us talk about that. So students, ideal solutions are the ones in which each component actually obeys the Raoult's law at all concentrations. Okay, so means Raoult's law under all conditions of temperature as well as concentration. So that will be known as an ideal solution. What are the properties? Now this is important because questions have been asked from these topic as well. Ki what are the conditions for ideal solution? So delta H mixing is 0, means neither the energy would be evolved or absorbed. Okay, means no energy would be evolved or absorbed. So delta H mixing is 0 and delta V mixing is also 0, means there will be no volume change as well when the two components are mixed. So no volume change will happen. Now for the ideal solutions, what happens is let's say if you are having two components A and B. So A will be having its own intermolecular forces, intermolecular attractive forces. B will be having their own intermolecular attractive forces. Okay, so when we are mixing them, there will be new forces arising between A and B molecules. Now what happens is for ideal solutions, the intermolecular attractive forces between AA and BB are nearly equal to those between A and B. Okay, so that is why there will be no evolution or absorption of heat and no volume change. So that will make it ideal solution. For example, now examples are also important. You must know at least 2 to 3 examples for each type of solution, and most importantly the ones that are given in NCERT, because questions have been asked from there. So whatever examples are given in NCERT, please remember those examples for this chapter. Okay, so solution of benzene and toluene, solution of N-hexane and N-heptane makes your ideal solution. Now if I talk about non-ideal solutions, so they will be the one which do not obey Raoult's law over the entire range of concentration. Okay, now there can be two cases. So either the vapor pressure could be more than that of what is expected from Raoult's law, or the vapor pressure could be less. Okay, now there is positive deviation from Raoult's law and negative. Where positive deviation means the vapor pressure is more. तो vapor pressure कब ज़्यादा होगा students? When the solvent solute interactions, means AB interactions are weaker than AA or BB interactions. So if AB interactions are weaker then AA and BB interaction, means the molecules can easily escape into vapor phase, means the escaping tendency would be more, right? So we can say if this happens, so the escaping tendency is more. And just now I have told you that the vapor pressure is directly proportional to the escaping tendency. So if AB interactions are weaker than AA and BB interactions, escaping tendency would be more, vapor pressure would be more, and so that's what it is written here. Vapor pressure is higher than what is predicted by Raoult's law. So for this, the delta H mixing would be greater than 0 and delta V mixing will also be greater than 0. Again, you must know about this interaction things, okay, that can be asked in the exam, and the examples also. Like the question could be asked like this: which of the following solutions exhibit positive deviation from Raoult's law or negative deviation from Raoult's law? So you must be able to answer that. So like we have ethanol and acetone, carbon disulfide and acetone. So they are having a positive deviation from Raoult's law. Okay, so this is the graph you can see. So otherwise this graph it has to be a straight line with mole fraction and vapor pressure we have taken, but positive deviation from Raoult's law, you can see this bold line. So the vapor pressure is more than what is expected from the Raoult's law. Okay. Now if I talk about the negative deviation from Raoult's law, the vapor pressure would be lower than what is predicted by the law. Vapor pressure कब कम होगा students? When the solute solvent interactions are stronger than AA and BB interactions. So when you are mixing the two solutions together, now they have strong forces of attraction than what was there in their respective time. Okay, so AB interactions, if they are stronger, so it means the escaping tendency of the vapors would become less. They would be having less tendency to escape into vapor phase. So vapor pressure would be lower. Okay, so that means it exhibits negative deviation from Raoult's law. Like delta H mixing would be less than 0 and delta V mixing also would be less than 0. Okay. For example, phenol and aniline, chloroform and acetone. So if I talk about chloroform and acetone, so they are having certain type of interactions. Okay, chloroform mein and acetone mein. But when you mix them together, there exists hydrogen bond. Okay, there exists hydrogen bond between the oxygen of acetone and hydrogen of chloroform. So because of this hydrogen bonding, now the molecules are strongly bind to each other. Okay, means the AB interactions become stronger because of hydrogen bond. So this will exhibit negative deviation from the Raoult's law. So the vapor pressure of the solution would be lower. This is the graph. So sometimes they can ask the questions by giving the graph also. So you must be having a little bit idea about the graph as well, ki what the graph will look like. Okay. Now if I talk about azeotropes. So azeotropes are those mixtures which have same composition in liquid and vapor phase. Means if you are having that particular mixture in liquid phase and when you boil it, okay, and they come to vapor phase, in that phase also they will be having the same composition and they boil at constant temperature. So इसलिए हम azeotropes को constant boiling mixtures भी बोलते हैं. We call them as constant boiling mixtures as well. Okay, now what is minimum boiling azeotrope? So which they are the ones which show large positive deviation from Raoult's law. Okay. So if they show large positive deviation from the Raoult's law, so जो vapor pressure the boiling point will be lower than that of the other two components. Okay, जब उनके boiling point जब हम उनको mix करेंगे, the boiling point will be lower than that. Example is ethanol water mixture which has 95% of ethanol. So that forms an azeotrope which has a boiling point of 351.15 Kelvin. Okay, so you must know कि minimum boiling azeotropes they show positive deviation from Raoult's law and maximum boiling azeotropes show large negative deviation from Raoult's law. So they will be having more boiling point. Okay. For example, nitric acid and water mixture which has 68% nitric acid. So these examples I have taken from NCRT. Okay, so keep that in mind that the NCRT examples, whatever examples are given in NCRT, they have been asked in your exam, Neet exam. So you can go through the PYQs, okay, and you will find out these kind of questions there. Okay. So now let us talk about solubility. So if I talk about solubility of solid in liquid, so there are certain factors on which this solubility depend. First of all, students, I hope you know what is solubility. It's actually the maximum amount that can be dissolved in a specific amount of solvent at a particular temperature thing is also important. At a fixed temperature, what is the maximum amount of solute that can be dissolved? Okay, so it depends on nature of solute and solvent, like dissolves, like so sugar and salt readily dissolves in water. Naphthalene and anthracene, they are organic compounds, so they are non-polar. They will not dissolve in water, but they will dissolve in benzene or carbon tetrachloride. Okay. Next, temperature. So if we are having a nearly saturated solution and if delta H is greater than 0, so the solubility increases with increase in temperature, that is in correspondence to the Le Chatelier's principle. But if the delta H is less than 0, so solubility जो है it will decrease with rise in temperature. Okay, but the pressure they do not have any significant effect because solids and liquids are highly incompressible. So solid and liquid की solubility पे there will be no effect of pressure. But if I am talking about the solubility of gas in liquid, so then it is influenced by the pressure that is given to us by Henry's law. Now Henry's law के ऊपर भी questions आते हैं. Okay, questions are asked from Henry's law in your NEET exam. So I'm telling you from which topics mostly you will get the questions. Okay. So Henry's law actually states that at a constant temperature, solubility of a gas in liquid is directly proportional to the pressure of gas. Okay. So solubility जितना ज़्यादा pressure होगा उतनी ही ज़्यादा solubility होगी gas की in liquid. Okay. So most commonly used form of Henry law is the partial pressure of gas in vapor phase is directly proportional to the mole fraction of gas. So if I remove this proportionality sign, I get KHX. So KH is the Henry's law constant. Okay, now this KH is important. I have seen some questions where the value of KH for different gases are given and you need to talk about their solubility. So you must know, students, that this KH is a function of nature of gas. Okay, and higher the value of KH at a given pressure, अगर जितनी ज़्यादा वैल्यू होगी KH की उतनी कम solubility होगी आपकी गैस की. Okay, because it will be like this na, P upon X equals to KH. So higher the value of KH, lower will be the mole fraction, means lower would be the solubility of the gas. So keep that in mind. There they will give you like 4 gases and their KH values. Okay, so you need to talk about their solubility. So higher the value of KH, lower will be the solubility. Keep that in mind. And KH value increases with increase in temperature. So it means solubility of gases increases with the decrease of temperature. जितना कम temperature होगा उतनी solubility of gas will increase. Okay. Now let us talk about the colligative properties. That is important. You will get a lot of questions as well as a lot of numericals from the colligative properties. So there are 4 colligative properties. You know, colligative properties are the ones which depend on number of solute particles irrespective of the nature. Okay. First one is relative lowering of vapor pressure. So we all know that whenever a non-volatile solute is added to a solvent, so there is a solvent, right? It has its own vapor pressure. But if we are adding a non-volatile solute to it, now what will be happening? Those solute particles will somewhat occupy the space at the surface also. So that escaping tendency of the solvent particles will decrease. So it means the vapor pressure will also lower down. So this is what we call as relative lowering of vapor pressure. Okay. So this relative lowering of vapor pressure का जो expression है, I'm not discussing the derivation here. If you want to know the derivations, you can see my lectures on solutions. Okay. उसमें I have discussed the derivation. Here I am just discussing the formula. So relative lowering of vapor pressure means if P1 naught is the vapor pressure of pure solvent and P1 is the vapor pressure of solution. So this is the lowering of vapor pressure. If I divide it with the pure vapor pressure, it becomes a relative lowering of vapor pressure. So delta P1 upon P1 naught. So it is equal to the mole fraction of the solute, that you must know. Okay. So this is known as relative lowering of vapor pressure and this is the mole fraction of solute. So mole fraction of solute को you can write N2 upon N1 plus N2, number of moles की form में हम लिख सकते हैं. Okay. Now N1 and N2 I told you, number of moles of solvent and solute. But if you are having dilute solutions, if we have a like dilute solution, so number of moles of solute would be very much less than number of moles of solvent. So वहाँ पे N2 can be neglected, so it will be N2 upon N1. Okay, so number of moles of solute divided by number of moles of solvent. So you know the formula for number of moles of solute will be given weight of solute upon molar mass of solute, and same goes with N1, weight of solvent upon molar mass of solvent. So यहाँ से this is the formula you will get. From here you can find out the molar mass of solute as well. So usually in numerical problems we get to know about the molar mass of the solute and solvent, so we can calculate that. Okay, so that is relative lowering of vapor pressure. Expressions are important. Now again we have boiling elevation and boiling point. So students, you know, boiling point is the temperature at which the vapor pressure of liquid becomes equal to atmospheric pressure. So try to relate it with lowering of vapor pressure. When we are adding non-volatile solute, the vapor pressure of the solvent decreases. Okay. So it means if I want to boil the solution, I need to now heat it to a higher temperature, okay, means the required temperature would be higher क्योंकि vapor pressure low हो चुका है. To make it equal to atmospheric pressure, I need to heat it more. It means the boiling point of that solution would increase. So that is what we call as elevation in boiling point. Okay, now the expression for elevation in boiling point you can see from here. So students, if you look here, what is happening? There will be rise in boiling point, I told you. So the increase in boiling point is given by delta TB. So it is TB minus T naught B. Now this T naught B is the boiling point of pure solvent and TB is the boiling point of solution. So this delta TB is called elevation in boiling point. Okay. And so this delta TB, it is actually directly proportional to the molality of the solution. Okay. And delta TB के लिए we will write it as kbm. Now this kb is the boiling point elevation constant or molar elevation constant. Okay, so as you can see from this graph, this is the boiling point of solvent, all right, and this is the boiling point of solution, because now more temperature will be required to make it equal to the atmospheric pressure. So this is the elevation in boiling point. Okay. So from this elevation in boiling point, we can easily calculate the molar mass of the solute. Okay, now molality is number of moles of solute upon mass of solvent in kilograms. Okay, so this is the formula. So from here you can write molality as 1000 into W2 upon M2 into W1, right? Number of moles of solute upon weight. Now this molality value you can put here, and from here you will get the value of delta TB. So these two expressions you must remember, and the value of M2 as well. Okay. So Kb ko, if you want to define Kb, you can say it is the elevation in boiling point when molality of the solution is unity. So the units is Kelvin kilogram per mole. Okay. So basically the expressions that you need to remember, this one and this one, the calculation of M2 also. Okay. Same goes with the depression in freezing point, students. Now freezing point is that temperature at which vapor pressure of substance in liquid phase is equal to the vapor pressure in solid phase. So whenever we are adding a non-volatile solid to the solvent, its vapor pressure decreases. Now vapor pressure kam ho jayega, so it would become equal to the solid solvent at lower temperature. So that's why the freezing point decreases. Again, the freezing point depression can be written as T naught F, which is for pure solvent, minus TF, that is for solution. And again, it is directly proportional to the molality. So if I remove this proportionality sign, I get Kf, which is the freezing point depression constant or cryoscopic constant. Okay, there we were calling it as ebullioscopic constant, and here it is cryoscopic constant. So again you can put the value of molality here. Okay, molality is given number of moles upon the mass of solvent in kg. So you will put the value of molality and you will get the value of delta TF, and from delta TF we can find the value of molar mass of the solute. Again, freezing point depression constant is the depression in freezing point when molality of the solution is unity. So the units are Kelvin kilogram per mole again. Okay. Next up, the fourth property is this is the osmotic pressure. So before that you need to understand what is osmosis. So let's say if you are having a pure solvent and a solution which are separated by a semi-permeable membrane. Okay. So the solvent particles will pass from the solvent side to the solution side, means from higher concentration of solvent to the lower one. Okay, this phenomena is called osmosis. Semi-permeable membrane, I hope you know, that allows only small molecules to pass through it and blocks the movement of solute. Okay. So that is osmosis. Now like here you have low sugar concentration, high water concentration. So यहाँ से water molecules will go to the right hand side where you have high sugar concentration and low water concentration. Now to stop this, okay, now to stop this movement, there must be some external pressure applied. Okay, so there must be some external pressure applied on the solution side to stop the flow. So this pressure is known as osmotic pressure. Okay, so osmotic pressure is the excess pressure that must be applied to a solution to prevent osmosis. Okay, so like here you can see this is the atmospheric pressure. In addition to atmospheric pressure, I need to apply some extra pressure which is denoted by pi, which is your osmotic pressure. And keep that in mind that osmotic pressure has to be applied on the solution side. Okay, so what is the formula for this osmotic pressure? It is directly proportional to the molarity. Now here we are talking about molarity, okay, or you can say concentration. So it is CRT at a given temperature. R is the gas constant, C is the concentration, and T is the temperature. So you can say C means the molarity, it's number of moles of solute upon volume of solution into RT. So from here you can say pi V is equal to N2 into RT. Now again, number of moles of solute means weight of solute upon molar mass of solute into RT. So from here M2 will be W2 RT upon pi V. So again from his, now you can see one common thing that from all these colligative properties you can calculate the molar mass of the solute. Okay. So there must you must know one thing here. This question have been asked from this also, that isotonic solutions are the ones which are having same osmotic pressure at a given temperature. And otherwise we have two types of solutions. The one with lower concentration or lower osmotic pressure is called hypotonic solution, and the one which is having higher concentration is called as hypertonic solution. Okay, so students, these properties that we have just discussed, so we are discussing them in the case wherever there is no dissociation or no association of solute particles. Okay, but if we are talking about the colligative properties, if we do the results, if we take the results experimentally, so the molecular masses हैं, they come out to be different than the theoretically expected value. Now why it is happening? Because the solute can undergo association and the solute can undergo dissociation also. Like if I am having KCl, so if I put it in water, so it will get dissociated into K plus and Cl minus ions. So in that case, the number of ions, the number of moles of solute that I am having, it will be more than what is expected. So obviously the molecular mass would change. So to express this change in or abnormality in molecular masses, molar masses, Van 't Hoff factor was introduced. Okay, so Van 't Hoff factor is known as I, which is normal molar mass, which is like a theoretical value, divided by the abnormal molecular mass. Okay, that has been experimentally determined. So it means another formula is observed colligative property upon calculated colligative property, or total number of moles of particles after association or dissociation divided by total number of moles of particles before association or dissociation. Okay, like association, so whenever there is association, like if I am talking about acetic acid, so वो dimerize हो जाता है, it dimerizes, okay, in water. So dimerize means here the value of I would be 1. Why? Because the total particles after association will be 1 and before dissociation were 2. So यहाँ पर I की value कितनी हो जाएगी? 0.5. So for I is less than 1 for association. Okay. So from here you can, let's say initial particles were 1 and final number will be 1 minus alpha plus alpha upon n. Alpha is the degree of dissociation. Okay. So from here you can find out the value of I. Same goes with dissociation. Like if I'm talking about KCl, so here number of moles after dissociation are 2 and before dissociation were 1. So in that case the value of I will come out to be 2. It is more than 1. So whenever we are talking about Van 't Hoff factor, so the colligative properties will be having modified expressions. Okay. Like relative lowering of vapor pressure mein I will multiply it with I. Now similarly for boiling point, delta T will become I kbm. Same goes with your freezing point. and with the osmotic pressure you have to multiply with I. So this is how students you can have the modified expressions where you have to talk about the I value as well. So whenever you have numerical problems, you will see कि most of the numericals are asked in the NEET exam from abnormal molar masses also. So you need to know the concept of I as well. Okay. So now students, so I have taken all the important topics for you. We have revised them. Okay, so try to solve all the PYQs and all the questions from NCRT for this particular chapter. Also go on the MemoNeet tab. There you will find line by line NCRT questions. Please try to solve them and then your chapter would be complete. So actually in BPT 3 also you have done the revision of this chapter. Now this chapter will be completely understood if you once again revise it. Okay. So all the very best for your preparation students. Do like, share this video and comment also. If you are having any doubts, please let me know. If you are liking the lectures also, then do also let us know using the comment section. Okay. So thank you so much students. Take care. Bye-bye.